put that to the side. And we're looking at 77. Nope, next page. We're only doing one lesson on 77, so you don't have to cram in lots of them. Okay, so 77. What we're looking at, we are looking at restrictions on rational expressions, even though there's an S there. So, again, rational means a fraction, so I'm looking at restrictions on fractional expressions. We are dealing with fractions again. Now, we know some of this stuff already. When I'm dealing with fractions, what restriction do I have when I am dealing with fractions? What cannot be in the denominator? I can have a negative in the denominator. What can I not have in the denominator? If I have it, just think about fraction. Don't overcomplicate it. What number can I not have in the denominator of a fraction? 0. So we are going to use that to help us today. That is how we're going to figure out what my restrictions are, is we are going to think to myself, what values will give me 0 in the denominator? So, a couple things we're going to do. First thing you're going to do is you are going to factor, which we practiced on the warm-ups. You are going to factor the numerator, which is the top, numerator, and denominator. So you are going to You are going to factor the top and the bottom of the fraction, just like we did on the warm-up. So you're going to do that first, factor the top and bottom. Now, if you can't factor it, you just leave it there. So there may be times where you can't factor the top or the bottom. You should be able to factor at least once. Or you may be able to factor top and bottom. So you're going to look at your numerator and denominator. You're going to factor it first. Then you're going to check. So you're going to find the x values, or it might be in the, how do I want to say this? And my x is if we're working with x variable. We're just going to find, you can just say the values. Find the values that will get the denominator equal to 0. Okay, it sounds more complicated than I think it will be. I didn't use x values because you might have different variables. But we're going to look, and we're going to look at the denominator and say, okay, what values, if I plug in for that variable in the denominator, will get it equal to 0? And those will be the values that cannot exist. Those will be the restrictions. So you're going to look at the denominator, and you're going to say, what values, if I plug in, will give me 0 in the denominator? And those will be the values that the variable cannot be equal to. And it'll make more sense once we look at an example, I think. The third step is to cancel out like terms. Because we know if I have the same thing on top and bottom of a fraction, they cancel out because they equal 1. So we're going to cancel out like terms. So factor top and bottom, tell me the restrictions, so tell me what numbers the variables cannot equal, and then cancel out like terms. Okay, we're going to look at a couple. I think when we look at a couple, it'll make a little more sense. Those are the 3 steps. Okay, let's look at one like this. R minus 6 over R squared minus 11R plus 30. Why is this a rational expression? We talked about the word rational. Why is this a rational expression? It's a fraction, plain and simple. Quadratic had x squared. Rational has a fraction, so this is a rational expression. Now, first step, we need to find, it's going to say simplify and then state the excluded values. So first thing we need to do is we need to factor the top and bottom. R minus 6, can I factor R minus 6? No, so it's already factored. Like I said, sometimes the top and bottom will already be factors, so you just leave it. The bottom, like we did on the warm-up, is a trinomial with a 1 in front. So what shortcut can I use? Two parentheses with r's in front. I'm a pirate. R's. That's funny. I'm hilarious. So two parentheses with r's in front. And where you need to find, like we did on the warm-up, two numbers that multiply to give me
negative
30 and negative. So they need to multiply to get a positive, add to get a negative, negative 5 and negative 6. So I know these seem a little complicated, but you can do the steps. What you need to do is you need to look and say, okay, what? Factor the top, factor the bottom. We know how to factor. We did it on the warm-up. Second step. So the first step is to factor. The second step is we need to figure out what x values will give me 0 in the denominator. So if you can't recognize it, you can take each part in the denominator and set it equal to 0. So if it's something, these expressions, r minus 5 and r minus 6, aren't hard to recognize. But if it's an expression you can't just look at, you can set each one equal to 0. So that will give me an r value of 5 and an r value of 6. So what that tells me is if I plug in 5 or 6, I will get 0 in the denominator. And which makes sense. Some you don't have to set them equal to 0 if you can just look at it. What minus 5 gives me 0? 5. What minus 6 gives me 0? 6. So r cannot be 5 or 6 because that will give me 0 in the denominator. So you're going to look at your denominator and you're going to tell me what values, if I plug in, will give me 0, 5, and 6. They cannot be equal to 5 or 6 because I cannot have a 0 in the denominator. You do not have to do this part right here where you set each part equal to 0 if you can look at it. Like these two I could just look at. But if it's a more complicated one, you may have to set equal to 0.
So that's the answer?
Well, that's the restricted values. So that's one answer. It's going to say simplify and tell me the restricted answer. These are the restricted values, which means I can't have those values. The third step is you're going to take it and you're going to cancel out the like terms. Now remember, you can only cancel them out if they are separated by multiplication. So what two things are the same? R minus 6, R minus 6, because this is the same as 1. When you have the same thing on top and bottom of a fraction, that's the same as 1. So I'm left with what on top? Not 0. 1 over r minus 5. And that is your simplified expression. So it's going to say simplify and then state the excluded values. So simplify, state the excluded values. That's it. Thanks. I'm glad you're so excited. Okay, let's look at 7, which is example 2. I'm talking to myself. Okay, let's look at one like this. A minus 2 over 10 times, A minus 2 over 10A minus 20. Sorry, it looks weird. So A minus 2 over 10A minus 20. First thing, look to see if you can factor. Can the top factor? No, so it stays A minus 20. The bottom, factor out a 10, so bring a 10 out front. What do I have left? A and minus 2. So that's step 1, factor. Step 2, state the restricted values. So I know A, what value, if I plug in here, will give me 0? 2. Now I have a 10 out front. Will anything give me 0? If I plug anything here, will it give me 0? No, there's no A. If there was an A with the 10, then it would be 0. But since it's just a 10, we don't have to worry about it. So my restricted value is A cannot be 2, because that will give me 0 in the denominator. And then the third step is to cancel out the like terms, which will be what? A minus 2, A minus 2. So that will leave me 1 over 10, because 10 is in the bottom. It's not, but that's okay. Okay, any questions on that? No. Okay. Let me do one more example with you. Let's look at about 5 more. 6 if we're lucky. Okay. Yeah, why not? Amen. Okay, let's look at example 3. This is a rational expression because it is a fraction. 30x plus 24 equals 40, or 30x plus 24 divided by 48. Step 1, factor top and bottom if you can. Top, take out a 6. 5x plus 4. Okay, so we're going to factor out a 6. This is why we reviewed factoring on the warm-up, so we could kind of refresh our mind. It's been a couple weeks. So take out a 6. 48, can I factor 48? No. Step 2, tell me the restricted values. Tell me what values cannot exist. So is there any value that I plug in for x that will give me 0 in the denominator? No, because there's no variable. If there's no variable in the denominator, any variable I plug in is not going to change this to 0. So there are no excluded values. So you can just put none. So there's nothing that I plug in for x that will give me 0 in the denominator. And then the third step, we need to reduce it. This is going to look a little differently. How can I simplify this? You can, a little different than what we've done up to this point. Think about the fraction. How can I reduce the fraction 6 over 48? Divide both by 6. The 6 will just give me a 1. So I'll just have a 5x plus 4 over, what if? 8. Yes, sorry. Brain freeze. 8. So if you have just numbers, just reduce it like a normal fraction. 6 over 48 is 1 over 8, and you don't need the 1 on top. So it's just that. Oh.
So if like the variable x is on top, you're not gonna have to solve it, right?
I don't have. Correct. I'm only worried about the denominator being 0. Yes. Does that help? Okay. Yeah, that should help you get started. Okay. So on the homework. 1 through 15 is what we're doing on the front page of the homework. If you guys are working well, then I will see. If you guys are working well, I tend to not want to get another assignment in. But if you're not going to use the time I give you, then I'm like, well, whatever, I'll do another lesson. So use your time, and we may not do another lesson depending on what the time looks like.
What is this one? The one
1 through 15 on the front page.